A listener reached out to me by email and said, "Hey, I had a meeting with a sales guy and he told me I definitely need a vector database. So is this a real thing or is this something he just made up because it's end of the quarter?" And I think this deserves an episode of AI without the PhD.
Artificial intelligence. Some say it will save the world. Others say it will take all our jobs. There is a truth in between. Let's speak about it. AI without the PhD, because somebody has to translate this stuff.
AI without a PhD because somebody has to translate this stuff. And today we translate vector databases. And first of all, it's a good idea to question things like that. If someone tells you you need something definitely, then it's usually worth to step back and at least give it a thought. Not because I think that sales guys are only in the favor of their own commission, but because I think if you are selling tools, you are some kind of biased. And again, it's always worth to think and make up your own opinion. And that's why we speak about that. So first of all, vector databases. So I guess every one of you worked in some sort with a database until today. Maybe working on an Oracle database, maybe working on a MySQL database. And if you're not that technical, you work with application that uses databases, and maybe you know this kind where you write select stuff from, and you get a ton of rows back. So this is all databases. Um, why do we speak now about vector databases? Let's see what problem they are solving. So a traditional search is like looking an exact word in your filing cabinet. So for example, you search the word invoice and you get all documents in your file system that contains the word invoice, which is pretty handy on the one side, but on the other side, maybe the word is not used in that way. So maybe you get invoices saying invoice, and you get other invoices having the title a payment request. So those documents wouldn't appear in a search for invoice because it's not the same word. And the typical search is a string pattern matching where it's really taking a look on the exact word. So you may work with ignore uppercase or ignore extensions or something like that. But at the end, you can work with wildcards. But at the end, even if you are really sophisticated in regex, you can't make a regex that detects invoice or detects a payment request when you search for invoice. So we need something else. So yeah, to find those documents, traditional search engine will miss that. And when I speak about traditional search engines, I also mean databases, to be honest, because at some point you query a database. So what we need more is a meaning-based search that tries to understand how words are related, and not because you truly understand it like a person, but in some kind it learned that certain words, phrases, or documents often live near to each other in other meaning. And this is where we speak about embeddings, and this is where we come natural to the place of vector databases. So I introduced another word, embedding. So let's speak about embedding. And I tried to explain it without being scary in the first place. So embedding is a way of turning text into some kind of location. And I don't mean a location like you have on Google Streets or Apple Maps or whatever, where you have streets, you have restaurants. I mean it in a higher sense. So a location in the map of meaning. So if we speak about the word car, this is closer to vehicle than to banana. If we speak about truck, this is closer to car and vehicle than to airplane, and so on. So this is where it works, and we can even carry this further. So if we speak about hotel booking, this is closer to a reservation than to a tax return. And coming from a way, so I think most of you guys know this. If we speak about knowledge databases, so you type in password reset and you get information about login problems. because this is in some kind related to each other and lives next to each other. So when we speak about embeddings, the computer does not store the sentence as a meaning in a human sense. It stores it as a long list of numbers. And so if you come back, or if we come back to the question of the listener, then this embedding gives you a piece of text information in the meaning space, and those embeddings usually live in vector databases. So I know this sounds very abstract, and I can go really down into the math of calculating those distances and speaking about algorithms. But I said that the title says it's without the PhD, so I try to keep it high level. So imagine we have a gigantic library where the books are not arranged alphabetically. They are arranged by what they are about. So all the books about traveling are sitting next to each other or nearby. Books about hotel bookings are closer to books about flight delays and all of that. So books about database backups are very far from books about how to bake a sourdough bread. And this is what embeddings do. And if you keep that in mind, it's a bit easier to understand. I know it's not the best example, and I'm completely open for finding a better example, but this is what I came up now after I put really a lot of thoughts into that, because the math for me is absolutely clear, but how to explain it in a way that we are not ending up with Greek letters here at that point. So coming to the question, now we know what the embedding is, and now what is a vector database? Vector databases are systems designed to store those meaning locations efficiently. So they store the embeddings. And it answers questions like, show me documents most similar to this question. So we're going back from the traditional select star from customers where country is UAE. And you get a list of all customers that are registered from the United Arab Emirates. We go more into a thing where we say, okay, this is my question, please give me something. So a traditional database find all the customers from the UAE, but a vector database would get the question already a bit different. You would say find documents that are probably relevant to customers in the Middle East, or in the United Arab Emirates, or in Dubai, or in Abu Dhabi, because UAE are more than Dubai, or in Ras Al Khaimah, because still UAE. So a vector database would find them. So a vector database is not magic in that sense. It's just it's a finding similar things machine. Let me go with a practical example, because I think this is now, after we spoke a lot about the theory behind it and the technique, I think we should work with a practical example. So we're using a business example. Imagine your company, and I think it's not hard to imagine because all companies are working like that. They have thousands of documents, they have policies, they have contracts, they have support tickets, product manuals, meeting notes, training materials, and PowerPoint slide that were created by people that are longer out of the company than you are in the company. And all of this knowledge is sitting in different places, in databases, in file systems, in wherever. And if an employee asks now, I'm as an employee who travels a lot, I have those questions. So that's why I come up with that. So my question is, can I expense a taxi from the airport if my flight lands after midnight? I think this is a valid question because, usually public transport is no longer available after those times. And so it's a valid question. I want to check this. So a keyword search may look for taxi, airport, and midnight, because that are the main words in that sentence that are important. So, but our travel policy says ground transportation is reimbursable for late arrivals where public transport is unavailable. And you see already the problem. There is no taxi, airport, and midnight in that sentence, but the sentence answers my question pretty well. So A meaning-based search has a better chance of finding the document and finding this exact sentence in there. That's why vector searches became very important when we speak about AI assistants and agents. Because if you want an AI system to answer from your company documents, you need to find the right documents in the first place. And usually you can't work with exact keywords. And the problem is if the AI can't answer from your company knowledge, it will or can't retrieve enough information from your company knowledge to give an answer, it will start to create the answer on the training material the LLM was trained on. And this is most likely not what your company want to express in their rules, policies, and regulations. And so this is why this technology, this meaning-based search and the vector databases came very popular with a GPT-style system. Because the large language models are good in generating answers. This is their home turf and they are really, really good in that. But they do not automatically know your internal knowledge, your internal documents, your prices, your policies, and your project history. So this is where we work with something that is called RAG, Retrieval Augmented Generation. So we get a question, and first we try to retrieve enough material to answer this question and to formulate our answer. And this retrieval step is usually some kind of a search. And this search can go against traditional databases, against API, or against the vector database. And so the answer is still not completely there. So we know now it's not a thing the sales guy made up, but we don't know if this is really needed. So let me do a reality check on, do you really need one? And the answer is maybe no. The thing is, the part where the sales guy comes with is how much of investigation, how much of understanding has he already at that point from your company and from your project's initiatives. So the question is not do I need a vector database? The question is, do I need a meaning-based search? And this is highly dependent from what you're doing there. So you don't need a vector database to do AI. This is the really important message I want to bring here. So AI doesn't mean you need a vector database, but it's a hint that you may think about that. And this is part what I spoke in the last episodes, where I spoke about that's really important to find the objective, the goal, and find the data you will use there. So you may need it if your user asks questions in natural languages. You may need it if you want to work with documents that are inconsistent in wording. You will need it when you try to work with similar cases, tickets, products, documents, and conversation. If you find similar cases in those data, you will need someone. And you have enough content that a simple search becomes frustrating. So if you just have a set of 20, 30, 40 documents for that use case, maybe a traditional keyword-based search will do the job really, really fine. So as I said in the early episodes, it's all depending on understanding what you want to achieve and how you can get to that point and what data you need to pull there. So when do you don't need one? You may not need one if you search structured records, if your data is small, and if a keyword search is fine. So if you go, for example, and have a chat open, and the question is, are all invoices for customer 42 paid as of now? Then you don't need a meaning-based search because you have a fact already in that sentence. It's 42, it's a number. You can go to a traditional database, look it up, pull all the data, feed it into your LLM, and then you can work with it and it can generate a proper answer from that. So then your problem is more bad data, poor document management, and unclear process. If you have this and you still don't come to a good result. So if you have fact search and you don't get a good result, the data is the problem. And Messy data is not fixed by another style of database. If you have messy data in your traditional databases, it will still be messy in the vector databases and in the embeddings. So please don't try to fix a data problem with another style of database. It's always good to fix the data problem first, and then you can go on there. So how can I find out if the sales guy is generally interested in selling me a vector database because I need one versus maybe it's more about commission? So you can ask them questions. What problem becomes impossible, slow, or unreliable without a vector database? I think this is a pretty fair question, and if the person can't answer that, you probably don't need one. Then ask what are searching for. Do you think we search for exact facts or similar meanings? And in the worst case, again, you don't get an answer. In a better case, you get the answer that the person understands that you're searching for similar meanings. If the person says self-confident, you're searching for facts, then you unveil a not so generally approach to get your vector database, because then you can stick with the old ones. So if the question is what's customer 42's outstanding balance, you don't need a semantic similarity. You have a clear identifier and you're good to go. So there's no reason to change the database. If the question is find support tickets similar to that customer complaint, then a good vector search will support this use case pretty good. So yeah, let's speak about one misconception, and this is really important for me because I see that in the field very often. And this is a vector database doesn't make your AI truthful. AI is designed to, or LLMs are designed to give you answers. And those answers are generated. And the better the data you feed to the model with a RAG, the better the answer most likely is. But there's one caveat we should discuss, and this is giving too much data into the model. So there's an amazing paper out by OpenAI, and they said LLMs will always hallucinating. This is not a technical issue. This is not a bug, and this is in the algorithms that drive LLMs. So if they can't give a proper answer, they will do a best guess. And this happens if you have too less data, but it's also happened if you give them too much data, because the token range is limited, because there's some compression algorithms already in there, and you're limited by the capabilities of the model. So just giving all your company knowledge every time into the LLM won't save it as well. So if you work with vector databases, it's not a guarantee that all the answers of your LLM will be truthful at that point. And it's technically not possible. And there's no guarantee given. And therefore, you should still supervise the answers the LLM spits out, and make sure that if there is something untruthful in it is discovered very early, so you can fix it, and you can also then check with your data. This is I think we should keep it here, and let me wrap things up, because I think that's a pretty important and a pretty tough topic to understand, especially if you're not technical. And I hope I was able to explain it at least to some certain extent. And I really encourage you to do maybe a bit further reading here if you're in the situation. So let me wrap it up. A vector database is not the brain of an AI system. It's more like a good memory index. And it helps finding things that are related in meaning. This can be powerful, but it can also be absolutely unnecessary. So there's no yes or no answer here, and I explained that earlier. So the next time someone says we need a vector database, the correct answer is not yes or no. The correct answer is, where are we trying to find our current, or what are we trying to find that our current search can't find? And this answer should lead you the way down there. So with that, I hope I was able to translate this stuff. I wish you an amazing day and all the best. See you next time.